Okay, so I'm going to make a front end for a zero knowledge proof smart contract. So this is the latest version of Web3 modal. I've already got a React app set up, so let's read the documents. So installation Web3 modal offers an out-of-the-box support for React and integrates very well with popular React hook library called wgami. Okay, so obtain a project ID for Wallet Connect Cloud. Okay, I will do that. So here's my project ID. So let me install the dependencies. Let's add these imports. And then configure wgami and Web3 modal clients. Let's copy this. And we need the project ID. We're going to want a button at some point. Start. Okay, so that all ran without any errors. Just to see what it looks like, I added the Web3 button, and that brings up this thing here. So I use Frame, so let me bring up that. So these are my two test accounts. Okay, so if I click on Frame, Proof, and there we've connected. I'm going to make another file to build the user interface in, just to make it more clean. Page. Next, we're going to do the UI work, and I'll be using Material UI. So go to Getting Started, Install. And I will install the icons as well. So now we go about building up the user interface. So to start with, we're going to want an app bar. I like the layout of this app bar, so I'm just going to copy all of that and then work from there. Okay, so now we've added this component. It's simply a case of modifying it to suit the needs. So I'm going to flesh this out and stylize it a bit. Okay, so I've stylized and refactored what I had. I've got three contexts now. I've got play, a chat, and about. So connect wallet. You select your wallet, you approve the connection, and there we've connected. I find that as soon as you get a user interface that lets you use some code as an end user would, you discover things that you wouldn't otherwise discover. So even though it's going to be buggy, I'm going to deploy to the testnet the contract as I've got it at the moment. Fill out the hard hat config to add the network, so Polia, and bring in the URL and the private key that will be used to deploy. And then we need a deploy script. Hard hat documentation has an example. So what do? I get a wallet address using get signers because my constructor requires an address. Then I get the contract. We deploy with this function here. Hit enter, and away we go. So Web3 modal uses the wgami library in the backend. We need to set the chains, and Sepolia is one of the included configurations. So all that's needed to do is to pass that name to the chains item of the object of the connector. If I connect my wallet, so I've now connected on the Sepolia network. So the next thing to do is to link up with the contract. So we have this API, this function, get contract. The wgami library has a hook for is connected. So now we've got that we're connected. Using the use effect hook and then passing the is connected value, we can monitor the change of state, and that is needed because we will need to initialize the contract if is connected. If the value changes to true and the contract hasn't been initialized, we will call this passing the address of your deployed contract and the ABI. So play connect wallet, and there I printed out the contract object. So now the contract object is available to start calling functions on the smart contract. One of the actions in the wgami library is read contract. So make sure you import the object read function, and then take that example there, read contract, and it returns the type from the ABI and the function name. So the function name will be playable. I need some way to call the function, so I need to import the UI component. When I call the function playable, okay, and that's logged true. How do we call a write function? Let's look down the actions, write contract. Okay, so we need these two imports, prepare write contract and contract. So in my test script, I tested the function start game. Okay, so I'm going to make a wrapper function for that. Prepare the function, replace the address with your address, replace the ABI with your ABI, and replace the function name with the desired function name. Start game. Args optional. Args call write contract, passing the config as the argument, then result. The next thing to do is to create these arguments. Let me look back at the test script. I need to recreate all of this. Okay, so I'm creating a random game ID. I'm signing it. Call this function, sign message, success. So there's my signed message. I need to do the zero knowledge proof stuff. Okay, so I've just split up the signature values into R, S, and V, and then due to the constraint of the size, I have to shuffle about the R, S, and V values so that they are smaller than this big number. So go to the snarkJS GitHub and get their snarkJS minimize file. Create a static folder for your React app and save that in there. And then go to your index file, public index, and then you're going to want to include this snarkJS library. Once it's included, you can then access it using the window keyword. Copy this. So we need to create the signals, and the signals are the inputs to the circuit. Let me just remind myself what those are. So these are the signals. I can just copy what I've done in the test script. Now I need the WASM file and the key. Here's my key, and in the JS folder there's the WASM. So I'm going to make them accessible. So this function is just replicating what was done in the test script. So when I click this button, I will call this a random uint 256, get the input signals, do the proof, generate the call data, and then send it to the contract. Call this function, sign it. That signing will be done in the back end eventually. And now do the transaction, sign the transaction, proceed. So here's the solidity function. So it checks the signature by recreating the RSV values from the inputs. Then it does the zero knowledge proof using this imported library function, verified proof. So the transaction has gone through. So the capture events from the contract, the wgami library, has got this function, watch contract event. So that's that. So now the next thing to do is to flesh out the user interface and implement the rest of the smart contract functions in the user interface. And then I'll go on to do the back end. And in the back end, I'll be dealing cards for the game and doing the signing to make sure that cards are dealt fairly for the players.